Hey there, it's Professor McDonald. Tonight I am doing a special additional recording to supplement some of the extra questions that I've been finding in my inbox. Normally, I just answer questions during our class meetings, or if it's a fully online class, I enter their questions twice a week in a recording. And this is a special extra one for these questions from Lesson 5. Lesson 5 has been extended. The due date has been extended. You can check for the announcement in Blackboard so that you know what the new due date is. I did not change it on the agenda, but you can make a note of that on your copy. And it's the only assignment that has changed. I also wanted to point out to all of you a resource that is available for Lesson 5, which is right here called the Lesson 5 presentation with videos. And so you have direct links to each of those videos there, and then you can go through the individual sections of the lesson for reference. And I find students get a lot of use out of that resource. All right, so now with the preliminaries out of the way, let's answer your questions. One of the questions I got, let's start with these are all from GLA 5, and this is question number 10. It says, suppose a jar contains 12 red marbles and 40 blue marbles. So 12 red, 40 blue. If you reach in the jar and pull out 2 marbles at the same time, find the probability that both are red. So I've made some notes already here. I've just recorded that we have 12 red marbles and 40 blue marbles, which gives us a total number of marbles is 52 marbles in the bag. Then I noticed that we were drawing out 2 marbles, and since we're pulling them out at the same time, we will treat this as multiple trials without replacement, which makes these dependent events. And we will be using the multiplication rule since we have multiple trials. So we can denote the question that we've been asked to find the probability that both are red is to say that the probability of the first one being red and then the second one also being red. So a shorthand way to say this is red and then red, or just put RR to show that they happen in succession. So on the first trial, we want to calculate the probability that when we pull out the first marble, we get a red. And let me just rewrite that a little differently there. All right, on the second trial, we want to calculate the probability of pulling out a red, but under the condition, so use the given that symbol, under the condition, or given that, we already pulled out one red and we didn't put it back. So to calculate the first probability, we're going to look at the number of red marbles out of the total number of marbles in the bag. So we're going to calculate 12 divided by 52. That, as a decimal, comes out to this number. For the second trial, we will have one less red marble in the bag and one fewer in the total marbles in the bag. So both numbers reduced by 1 there, and so as a decimal, we have this number. Now, the multiplication rule says you calculate the probability for each trial and then you multiply them together. So you can multiply them with the first cell times the second cell, or you can also use the product formula in Excel and just select those cells. So here is my answer, 0.4977. Now maybe I didn't put, oh, I see, I didn't put my 0 in front of the 4 after the decimal, so that should be good now. A group of 8 people that we're going to select 2 of them from, and we want to know what is the probability of selecting the 2 oldest people in the group. So I've made some notes here. We have n items available to choose from, and n is 8 here, since we have 8 distinct different people to choose from. R would be the number of picks that you can make out of those 8. So how many of the 8 do you get to choose? And we're doing 2. And this is without replacement. Okay. And so the trick to this problem is figuring out how many different ways you could get a collection of 2 people. And so you'll want to choose the correct counting rule here. Now, the counting rule strategy that I've recommended when trying to decide which counting rule applies is to begin by doing the organization step that I've done here, and then to determine if order matters. So we found that order does not matter. So this is going to be the combinations rule. Also, just as a note, if we didn't have these selections being done without replacement, then we wouldn't be able to use the combinations rule. Here it's implied the two oldest people, well, there has to be two separate oldest people. So certainly we couldn't have selected one person and then put them back in to select for the second trial. So it's combinations rule, and we should look up the formula for the combinations rule so we can see how that is done mathematically. We should know how to calculate this with the mathematical formula and then also do it with the formula that Excel has for combinations. So notice in the formula I'm going to need n factorial. I'm going to bring this up here. So n factorial is where you take whatever n is, and in this case it's 8, and you go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 2 times 1. That's what we mean by 8 factorial. So we see you get that number. You can also use in Excel the factorial feature or the factorial function on the number 8 and get that answer that way. So that's going to be the top of my calculation, the numerator. Then we want n minus r. So that was n factorial. Then we want n minus r factorial. So what is n minus r here? Well, n minus r is 8 minus 2. So what we want is 6 factorial. So again, we can do fact, and you can even put this inside like this. Subtract them, factorial 6, or in other words, 6 times 5 times 4 times 3 times 2 times 1, 720. We also want r factorial. So r here is 2. So 2 factorial would just be 2 times 1. Now we can use those in the formula to get our combinations. So we have n factorial divided by n minus r factorial times r factorial in the denominator. And there I have my answer. Now I told you that the combinations to get what this would be 8 combined with picking 2, so 8 choose 2. You can get that same answer using the combinations formula in Excel. So you would just put in the number 8, comma 2 for how many you're choosing and get that. Now, why did we want that? Because these are all the different ways we could choose two people, and only one of those would be the two oldest people. So now the answer to the question, the probability of choosing the two oldest people would be equal to 1 out of 28. So the answer as a decimal is right there. All right, so now we have a person going to a party was asked to bring 2 different bags of chips. Going to the store, she finds 19 varieties. How many different selections can she make? So again, you want to organize the items to choose from. So we have 19 varieties that we can choose from. So that would be 19 varieties. Or we'll just say 19. And then how many do we get to pick? So our picks, or our that we actually select, and it says bring 2 different bags. Okay, so that means that we're doing this without replacement because the 2 types of chips can't be the same kind. 2 and without replacement. And so I'm leaning towards a combination again for this one because it doesn't matter whether you get Doritos and then Lay's, original style, or, Doritos and then barbecue, or barbecue and then Doritos. The order does not matter. So again, this is combinations. And this time I'm just going to use the Excel formula. So I'm going to be calculating 19 choose 2 using combinations formula, COMBIN, and then 19, choose 2. 171 ways. Now notice they did not ask what's the probability of making a certain type of selection. In the last problem we were asked for a probability, so we did do 1 divided by the number. Here they're asking us how many different selections, so we actually gave that number instead of a probability. And also just remember to check when you're giving your answers if they are asking for how many or if they're asking for a probability. If they're asking for a probability, the answer has to be between 0 and 1. All right, so let's go on to the next one. All right, so we are moving on to question number 21 in lesson 5 GLA, and it says that, right, now this is question number 21. It says 5-letter words are formed using these letters, so we're allowed to use these letters to form 5-letter words. So now they're asking us how many of these words can we make? And we're going to break it up into different sets of conditions. So as we add more conditions, we will change the solution slightly. So we can begin by just trying to organize the information that's given. Notice that we have letters to choose from, right? So that would be our N. N is your items to choose from, right? So N is 7 letters that are available. And R is going to be how many you're going to use or how many you're going to pick. So we're going to make 5-letter words, therefore we're going to have to select a letter 5 times. So now we have 5-letter words, okay? Now, normally after we determine how many we're going to be picking, we often want to ask the question, should we be doing this with or without replacement? But it's going to be different for these different parts. So we'll ask that question now, but we'll kind of organize it. I guess we'll answer it with or with replacement. We'll just say with or without replacement right now, and we'll answer that with the different parts. All right, we also should ask if order matters. Okay, so when you're forming words, does it matter the order of the letters? So if I use the letters D-O-G to spell out dog, and then I rearrange those letters some way, like G-O-D, do I have the same word? I used the same letters, but I changed the order. Is it the same word? No, it's not, right? It makes a different word. So that means that order matters. In all of these parts, order will matter. So the fact that order matters means order matters here, so not the combinations rule, okay? So the trick to this question, since they've asked us how many, we're going to be using a counting rule each time. And the first one that you should always consider is combinations, because it's the only one in which order does not matter. So the fact that order matters here means we have eliminated one option out of the counting rules that we could choose from. All right, now that we know it's not combinations, we know it's a type of permutation, we can start going through the different parts and see which permutations rule would best fit. So in part A, the condition is that there is no condition, no additional condition, okay? So without any additional condition, that means that when we ask this question are we allowed to use replacement? In other words, can I, for instance, form a 5-letter word where I used the letter E twice? Is that okay? Or do I have to do it without replacement where I can't use the same letter more than once? And here, since there's no condition, that means we can assume that replacement is okay. Repetitions are allowed, right? Okay, that's good to know because that eliminates some more options from our list of possibilities. And where am I getting my list of possibilities? Again, I'm going to that slide that has all the counting rules laid out on it. So to be able to use the combinations rule, you can't have order mattering. So we already ruled that out. To use the rule with identical items, some of the items that you're choosing from have to be identical. In other words, when you switch the order, it doesn't make a difference. But the items that we're picking from are actually completely different. There's none of them identical. So we can bypass that option. This one's out. The next one down here, NPR, you have to do this without replacement. And same thing for factorial. So we can bypass those as well. And we find ourselves arriving at the fundamental counting rule. So what we are doing is we're saying that we're just going to use the fundamental counting rule, assuming that we're going to make 5 selections. And I'm going to make a little visual here. I'm just going to have 1, 2, 3, 4, 5 boxes that I could fill with a letter. To get a visual, I'm going to pick one of those 7 letters and place it here. So let's say I choose the letter A. So when I chose that, what was the probability that I would choose A? And for every try, I always have 7 that I could choose from because repetitions are allowed. So now using the fundamental counting rule, the number of words that I could form is 7 to the power of 1, 2, 3, 4, 5, or 7 times itself, 5 times. So 7 to the power of 5 is my answer for part A. Right now, part B, no letter can be repeated in a word. So they're adding a condition here for part B. So now I'm just going to do the same thing I did before, but assuming that repetitions are not allowed. Okay, so then when I choose my first word or first letter, I have 7 letters to pick from, but I can't use whatever letter that was again. So for instance, if I picked the letter A is no longer an option for me, so I'm going to have to pick a different letter. And now there are only, say I choose B, then I only have 6 choices because A is gone, right? So I can choose B out of 6, so that's, and then so on down the line. So basically 7 times 6, and we have 5 boxes again to fill, right? So 1, 2, 3, 4, 5 boxes means I'm going to do 7 times 6 times 5 times 4 times 3. So that's the fundamental counting rule. Now, another way that you can do this is to use NPR. So you can do 7 times 6 times 5 times 4 times 3. Or if you use the permutations rule, that'll get the same job done. And so you would do permute 7, choose 5. And that part C says each word must begin with the letter A. So now each word must begin with the letter A. Okay, that's the only condition imposed here. So here I have my 5 boxes again. C, A has to be in the first spot, and then I can choose anything I want for the rest of them. Even if I wanted to, I could choose A, all the way through, right? So if I can do that, that means that for the, I could also choose B and D and whatever else I want, really. There's no other conditions imposed. Repetition should be allowed just as long as that first letter is A. Now there's only one way to choose A, right? I only had one option. I was forced to use A there. Now for the rest of them, I have 7 letters to choose from again. So I can calculate this with the product rule and get 2,401. Now part D is we want to say that the letter C must be at the end. The letter C must be at the end. Now, honestly, do I even need to calculate that? I mean, it's going to be the same answer as A, except, instead of the first spot being forced to be A, it's just going to be the last spot forced to be D. So it's the one way to choose that, and then all the rest you can choose anything you want. So you get back to that same answer again. Part E, the second letter must be a vowel. Okay, So if the second letter must be a vowel, let's go ahead and copy this down. So from my choices, remember I had A, B, C, D, E, F, G to choose from. Now, how many of those are vowels? All right, so I have A is a vowel and E is a vowel, and that's it, right? So the second letter has to be a vowel, so there's only two ways that that can happen. Now, all the rest of them can be anything, right? So I have 7 ways to choose all the rest of them. And that's the end of that question. And here's the next lesson. So I'm assuming that since the video that's attached here shows the calculation using the mathematical formula, that this student probably wanted to know if there was a faster way of doing it in Excel. So yes, there is. You can use the permutations formula with 13, comma 3, and that will get you the answer. However, I do caution you to learn how to use the mathematical formula anyways, because it's helpful to your learning process. It'll help you sort out when certain things are appropriate or why. Um, I tell students, even though you can do things in Excel that are much easier, in order to be able to know that you should use that, you would have had to have experience with doing things the long way so that your brain starts to understand or be, it's really hard to make someone believe me, but until you've done things the long way enough times, it's like your brain doesn't get the maturity to know when to use a certain formula. So a question like this, really, you should be using it to practice the mathematical formula and then check it with this. So to do the mathematical formula, you would be using um, the calculation here, NPR equals n factorial over n minus r factorial. And what this is when you start with assuming that you're going to be doing selections without replacement, NPR is used when you are select R items. So in other words, some items out of n total items, okay? And you're going to be doing it without replacements. That's when you use this, and of course order matters because it's a permutation, okay? So then you will calculate n factorial and n minus r factorial and divide them.